So here's the homework that goes with that lesson, or extra practice. And the best part would be, of course, is if you practice without me first and then play the video and see if you did it right. Or you can do it with me, press pause when you need to, whatever you need. The amount of bacteria present in a certain culture each day can be represented by that equation. It says find the average rate of change. That's Aroc. So Aroc is using 2 points, and that's between the first and fifth day. So we're going to start with 5, subtract 1, and then 5, subtract 1. So that's y2 minus y1, x2 minus x1. So when you plug in 5, you get 823. You plug in 1, you get 135. That's divided by 4. So this answer is 172. Now, 172 what? Because it's an application, and when you find the derivative, you're finding a rate. We need 2 units. So it's 172 bacteria per, and the other rate is day. So 172 bacteria per day. So the average rate is the bacteria is increasing at a rate of 172 per day. That's how we'd read it. B, find the instantaneous rate of change in the second day. So the instantaneous rate of change is the derivative. So we're going to find the derivative first. That's 3 times 8, subtract 1 to the exponent. 2 times negative 35, that's negative 7, subtract 1 to the exponent, and 134. Next, we're going to substitute in 2. And then when I plug in 2, the answer is 90. So 90 what? So the answer is 90 bacteria per day. So the rate the bacteria is increasing on the second day is 90. The average rate of change is 172 between the first and fifth day. 4. Jared's hourly wage changes based off of his length of service with the company. This wage can be represented by this equation, the square root of 2x plus 7. So find the average rate of change. That would be Aroc between the 8th and 2nd. So that would be f at 8, subtract f at 2, 8 take away 2 in the denominator. Slope formula. So plug in 8 and you get 11. Plug in 2 and you get 9 divided by 6. So when you put it together, that is 2 divided by 6. And in terms of money, that would be approximately 1/3 or 33 cents per hour, right? Year. What is it? Hourly or change? Oh, second and 8th year. So the average change in a salary increases by 33 cents per year. Pitiful. B, the instantaneous rate of change in the 5th year. So for that, we need to take the derivative. Now, in order to take the derivative up here, instead of the square root of 2x, I need 2x to the 1/2 plus 7. Now, to use some shortcuts here, we're going to go 1/2 times 1 in front, and then subtract 1 to the exponent. So 1 take away half is negative 1/2. Now, this is what's called a chain or a hook. The base, do you notice that? The derivative of 2x is 2. That's part of the shortcut. So if the derivative of the base gives you a number that is not 1, you need to include that there for the chain. And then the derivative of 7 is just 0. Now plug in change in the 5th year. So now plug in 5. And then see what that change is per year coming the 5th year. Here, let me take my calculator and do that. So it's 0.5 times 2.5 to the exponent negative 1/2 times 2. So the answer here is 63 cents per year. So exactly during the 5th year, the average rate in the 5th year is 63 cents per year. So that's telling me already the more he works, the less change there is in this person's Jared's salary. So at the beginning, there's some change, and then as they work longer, more years, their salary stays pretty stable. All right, number 3. The average inches of precipitation in Miami can be represented by this equation. Find the average rate of change. That's Aroc. So the average rate of change, and it's between March and August. So we're going to just say that even though it doesn't tell you directly, I'm just going to go with it and say the 8th month, that X represents the month number and that X equals 1 is January, though it's not spelled out, and it should be spelled out. So the 8th month is August, the 3rd month is March, so it's 8 take away 3. So plug in 8, by all means use a calculator, that's 16.64. Plug in 3, and you get 3.94. And then divided by 5. I kind of look off an answer key here from the person who did it, but sometimes the answer key is wrong. So as I'm going on, I'm fact-checking to make sure that it was done correctly. So this look, I'm going to trust that is done correctly. So subtract and then divide by 5, and it's 2.54. But what? It's a rate. So in this case, it's inches per month. So what's the average rate of change from March to August is that it increases in precipitation at an average rate of 2.5 inches per month. Find the instantaneous rate of change. That's calculus. To find that, you take the derivative of what you see. Shortcut, 3 times negative 0.03 is negative 0.09. Subtract 1 from the exponent. 2 times 0.55 is 1.1. Subtract 1 from the exponent. And then 0.6. So that's negative 0.6. Then you substitute in. Now, what month? July. So that month for July is the 7th month. So plug in 7 in there. Again, the answer key is off. My answer key, they put in 5 for July. That does not feel like the 5th month. So negative 0.09 times 7 squared plus 1.1 times 7, take away 0.6. We get, let's try that again, 0.09 times 0.09, negative 0.09. Negative 0.09 times 7 squared plus 1.1 times 7, subtract 0.6. Let's see if this one gives me an answer that makes sense. 2.69. So that's what? 2.69 inches per month. So in the month of July, instantaneously it increased by this much, 2.7 inches of rain per month. Number 2, the amount of bacteria presented per hour after treatment can be represented by this equation. So I would think X is the time and F is the bacteria. So for hour. So find the average rate of change between the 1st and 6th hour. So to do that, the change in Y over the change in X, there's the slope formula. So plug in 6 and plug in 1. So if you plug in 6, you get 6 over 4. 12 take away 3 is 9. So 6 over 9. So you get 2/3. You plug in 1 and you get 6 divided by negative 1. You get negative 6. Right? No. If I plug in 1, I get 2 take away 3. So if I plug in 1, I'm pretty sure I get 2 take away 3, which is negative. You can't really have negative bacteria, so I'm just going to go with it anyway. 6 divided by negative 1 is negative 6. Perhaps it was 2x plus 3. Oh yeah, there was a mistake here. So I see on the answer key that this was changed to a plus sign. So let's do that. We can't have 2x subtract 3, because if you plug in positive 1, you can't have negative bacteria. So let's try this again. So if you plug in 1, you get 6 over 5. if you plug in 6, you get 6 over 15. And when you plug in 6 over 15, I'll just put that in right there. We'll just keep it that way. And that's over 5. Let's do some fun basic math. Multiply top and bottom times 3. So you got 6 take away 18. Now this answer is going to be negative, but that doesn't bother me, and I'll tell you why. And then times the reciprocal. So if we put this together, we get negative 12 over 75. I don't care about reducing it down. And that's bacteria per hour. Now, why is this one okay to be negative? Because that's a rate. That's not the number. That means it's decreasing. That's all that negative sign means. That means over time, the bacteria is decreasing. So on average, it's decreasing by that many bacteria per hour. So that's okay, because that's what that negative means. But when I plug in and get a negative answer right at the beginning, that does not make sense, because you can't have negative bacteria in your body. All right, instantaneous rate of change. And again, we're going to use 2x plus 3. We're going to use the quotient rule. So if we use the quotient rule here, it's the bottom times the derivative of the top, which is 0, minus the top times the derivative, which is just 2, of the top, bottom, and then the bottom squared. So let's just clean this up just real quick. So 2x plus 3 times 0 is 0. And then we have subtract 6 times 2. So that's negative 12 and 2x plus 3 squared. So that's the instantaneous. And then the instantaneous of the 4th hour. So when I plug in 4, that's 8 plus 3. That's 11 squared. So it's negative 12 divided by 11 squared. So exactly during the 4th hour, if I round it, it's negative 0.099 bacteria per hour. So that means it's decreasing at that rate. Turn the page. A cue ball, that's like from playing the game of pool, is dropped, compared to swimming in a pool, is dropped from a platform 125 feet high. There's an equation. H is in height, T is in seconds. And then it says the word rocket. So if a cue ball is dropped and then so on. So let's make sense of this. So a cue ball, so obviously this rocket part actually belongs down here. So let's make it just right. Gives the height and feet of the cue ball. There's a typo there from what I printed out from. So of the cue ball in t seconds. So obviously the next question, number 6, is about a rocket. There's just a typo. So find the average velocity. So to find the average velocity, we're going to plug in from 1 to 2.5. So we're going to plug in 2.5. We're going to plug in 1 and then subtract 2.5, take away 1. So it's okay that this answer is negative because it's a rate. So plug in 2.5, you get 25. Plug in 1, you get 1.09. Or 109, I meant. And then 2.5 to take away 1 is 1.5. So put that all together and you get negative 56. 56 what? And the unit is feet per second. So what does that mean? That means between 1 and 2.5 seconds, the average rate that the cue ball is falling is at that rate, negative 56. In this case, the negative there represents decreasing height or falling. Instantaneous rate of change. We need the derivative for that. So we're going to take the derivative. That's 2 times negative 16, subtract 1 to the exponent, and then the derivative of 125 is 0. At exactly 2 seconds, I'm going to plug in 2, and then I get my answer. And again, the negative just tells me it's falling, but the rate is 64 feet per second. So at what rate is it falling exactly at 2 seconds? And the rate is at 64 feet per second. So that's what the negative tells me. 6, a rocket, there it is launched from the ground. You're given an equation. Again, h represents the height, and t is in seconds. Find the average velocity of the rocket between second and 6th second. Here we go. So from 2 to 6 seconds, the average velocity here is found by going h at 6, subtract h at 2, and then 6 take away 2. So if you plug in 6, you get 1,374. Plug in 2, you get 586 divided by 4. So altogether, that's 197. And what are the units for the rocket? Feet per second. So on average, that's the rocket's velocity, 197 feet per second between second and 6 seconds. Now, what's the instantaneous velocity? That's now calculus. So first, I need to take the derivative using shortcuts. That's negative 32 t plus 325. Now plug in 8 seconds. And if you plug in 8, you get 69. And again, it's feet per second. Algebra, calculus. All right, 2 more, 7 and 8. So here the question is about a bicyclist. And the t is in hours, and d is in distance in kilometers. So units matter. Find the average velocity of the bicyclist. Again, there's a mistake there. Between the 2nd and 5th hour. So that's a bicyclist. So to find that, that's d at 5, subtract d at 2, and then 5 take away 2. So if you plug in 5, that should give you the answer 60. Plug in 2, 44.4 divided by 3. So altogether, that's an average speed that's really slow, 5.2 kilometers per hour. Find the instantaneous velocity, that's derivative. So to find the derivative of this, that's 2 times negative 3.4, that's negative 6.8 t plus 29. So there's using derivative shortcuts. The exact velocity at 3 hours, you plug 3 into that equation, and you get 8.6, and the units are kilometers per hour. All right, number 8. A baseball is hit towards the outfield following a path represented by that equation. T, this is what I care most about, T is in seconds, D is in distance traveled. Do we know if it's in feet? I'm going to write that down in feet. It should tell you in the equation, but it didn't. Find the average velocity of the baseball. So that is d at 3, subtract d at 0, divided by 3, take away 0. So what's the average velocity of that baseball as it's being hit? So that's 86 when you plug in 3. Plug in 0 and you get 5. Divided by 3, so altogether that's 27 feet per second. That's the average velocity of the baseball being hit. Find the instantaneous velocity, we need the derivative. So to find the derivative of this for instantaneous, that's negative 2t plus 30. Then plug in the second of the second second. So we're going to plug in 2 for the second second. And if we plug in 2, we get the answer 26, and that's 26 feet per second. So practicing average rate of change, 2 points. Slope, algebra, y2 minus y1, x2 minus x1. Instantaneous velocity, that, or instantaneous rate of change, that is calculus. That's limits, and then we can use shortcuts. That's another definition of what a derivative is. Hey, what is a derivative? It's the slope of a tangent line. The slope using 1 point. It's the instantaneous rate of change. It's the instantaneous velocity. All of those are correct definitions of derivative. Mr. GMAT, over and out. I'm proud of you as always, and until next time.